Artificial intelligence. Even if you haven't noticed it, you have now acquired all the useful notions to be able to understand what artificial intelligence consists of. Now let's start talking about it by going into more detail. Always remember that the purpose of this presentation is not to teach you a certain topic, but to provide the concepts useful for understanding a certain topic. For this reason, we are perfectly aware that we prefer the simplicity of general concepts to the precision and technical correctness of the explanations. Let's start with the explanation of the term artificial intelligence. The reason is that a chain of elementary modules, such as the one we hypothesized in our previous example, the one that built a rural image, is conceptually assimilated to a chain of neurons and synapses. Neurons are the individual elementary software modules, specialized in carrying out specific algorithms, and synapses are the interconnections that decide the sequence in which the modules are executed. The input that flows from one neuron to another, from one module to another, together with the initial parameters and those calculated in the course of the processing, determine the behavior of the next module, and so on until the final result. A software architecture that refers to neurons and synapses, and which is therefore called artificial neural network. Neural network architecture. Continuing with the analogy of the chain of modules that create the country image and the weather forecasting software. As we have already said, the weather forecasting software is the result of classical programming, in which a programmer, in an assertive way, writes step by step what the computer should do. He uses a human-oriented language and no longer machine code like the assembler, so he writes fewer instructions, but the end result is always a huge amount of instructions in machine code, executed by the computer, that is, by Alan Turing's machine. Neural networks can also be conceptually assimilated to a program. The architecture of a neural network defines how many intermediate layers there are, how neurons are connected between the layers, and how information flows through the network. This architecture is defined before any type of network usage. The training. A peculiarity of neural networks that justifies the name given to this architecture. Artificial intelligence. In fact, the functioning of neural networks is based on learning. During the training phase, which is a prerequisite for using the network, it is powered with a set of training data with known inputs and known outputs. The neural network is programmed to adjust the weights of the connections between neurons in order to obtain an output that is as equal as possible to the given output. And it does so with an infinite number of test cycles until it reaches an acceptable result. That is, until the results, which are always numbers, are similar to the default ones. Meaning that they fall within an acceptable range of values. The usual problem of the rigidity of numbers and bits is always present. This training process involves the use of mathematical optimization algorithms, such as gradient descent, to optimize connection weights. Example. Let's imagine we have a picture of a dog. In the first intermediate modules, the network could detect some lines, some edges, and shades of color that represent, based on its training, typically some dog's body parts, such as the ears or tail. Then, addressing the appropriate modules, the software architecture could combine these basic features to recognize shapes such as the dog's body or the dog's head. And with subsequent approaches, the artificial intelligence could identify that most probably the image represents a dog, based on the high percentage of weights given in each result. So it gives the answer. The neural network learns these characteristics through the training process that takes place on a huge set of labeled images of which the solution is also provided. The system searches for the mix of weights or numerical parameters to be attributed to the image, which allow it to obtain that result, crossing the network of neurons or sequence of elementary modules with the minimum deviation of values. Once trained, the network can be used to recognize similar objects in new images. A software architecture of this kind lends itself to developing software that processes complex problems without human intervention, because it provides the final result by proceeding in continuous approximations through multiple layers, with which they increasingly refine the analysis of the input. This is the reason why neural networks are so effective in overcoming the rigid limit of the comparison between two numerical values that we inevitably run into with classical assertive programming, where the programmer has to give commands in terms of do this, do that, calculate according to this algorithm, and compare in terms of equal, different, greater, less, with the difficulty of contextualizing the result. Let's do the last exercise and try to design our own system based on artificial intelligence, to make you understand that it is an innovative system in the way to design the software. This is, as always, an exercise that is meant to make you understand and not to teach you computer science. Suppose our system must be able to solve algebraic equations. And let's imagine that we want to do it in the classic way, that is, using one of the most common programming languages. A first software module we need to project should contain the necessary logic to recognize the parentheses and determine which operations to perform first, starting from those contained in the innermost parentheses. As we know, the computer is a calculator, and as such its electronic circuits act in such a way. Minus sign times minus sign gives plus signed result. And minus signed times plus signed gives minus signed result. But only for example purpose, let's suppose that we want the computer to learn this mathematical rule through the artificial intelligence technique. So let's suppose, for example, that we develop a specific module for learning this mathematical rule through the artificial training system. Once we have built the system with all the necessary modules, we provide it with a large number of equations including their result. The system identifies the parentheses and the sequence of operations to be performed, but in the face of multiplication, it will do all the tests to verify with which combination of signs it can obtain the result provided. It is clear, given the trivial example we wanted to consider, that the conclusion will always be 100% of cases where if you use minus times minus equals plus signed and minus times plus equals minus signed, you get the correct result. And in all the different combinations, like minus times minus equals minus, the result is always wrong. At this point the system has learned that in the face of a multiplication of minus times minus 100% the result is plus, and therefore it applies the rule. This is the artificial intelligence. But don't forget that in both cases in which the computer applies this rule, because it is built to respect it, and in the case in which we make it learn the rule with the artificial intelligence technique, that is, by making it work in an infinite number of cycles to try to find which combination satisfies the results we have given it, it is never aware of what it is doing. Similarly, in the case of artificial intelligence that generates a text on the basis of a simple request, relieving us of having to do it ourselves, the text is constructed by the computer taking words, phrases that for that specific topic have produced a high percentage of probability during the training phase, and therefore it proposes them to us. Sentences arise from the juxtaposition of words, which the computer sees only as sequences of bits with a high statistical probability weight. We find everything extremely useful, almost unbelievable, without realizing that we are the ones who attribute value to the text, probably because we find its style new to us. We would not have been able to write it this way. But the computer offers it to us only because these sentences are part of its enormous memory, which has forfeited sentences already written by others and statistically the most used. We want to make one last mention about the current artificial intelligence products made available to the public, free or almost free. We're essentially talking about Microsoft Bing and ChatGPT. But Google is also preparing its own commercial solution. Bing uses this new technology to speed up and summarize in few seconds the content of web pages that deal with a certain topic that we are interested to and we requested. Therefore, learning that takes advantage of the enormous processing speed of computers is based on taking in everything that has been written and published on the web. Instead of using the classic search engine to get thousands of pages in response, obviously limiting ourselves to read at least the first few ones on the list, we get a well-structured summary talking about the argument we are interested in and giving all the necessary cross-references to verify the sources from which it was created. Of course, the quality of the information depends on the quality of the web pages from which it has been originated. Garbage in, garbage out. ChatGPT, on the other hand, is a more orthodox artificial intelligence system. It has been trained with information going up to 2021 and is currently being worked on updating it and allowing it to access the web for the latest information. However, these are two different neural networks, with different modules, or with different neurons if you like. Although Bing has also recently used ChatGPT in its processing, demonstrating that it makes no sense to redesign software that has already been written. The wording of the questions, what is technically called the prompt, deserves your attention. You can write a few words in a prompt, or express yourself as you would with a real person. Bing will interpret what you said and will repeat your request, synthesizing it and giving you the opportunity to learn how to be concise, as is usual for a computer machine. Bing then processes your request and provides you with the response. It is useful to reflect on everything we have already said about the architecture of an artificial intelligence. A set of the modules specialized in carrying out specific processing that, like neurons, are activated in sequence by receiving the results of the previous module or neuron as input. By many approximations, it arrives at the final result. Therefore, if we want the artificial intelligence to create a document, or a summary, or any other text we have in mind, it is better to make the request explicit with as many details as possible, specify what we expect in details. We will certainly get more satisfactory results. We must consider our prompt as the new way of computer programming. The more detailed we make the request, the better the result will be. We've come to the end of this roundup of computer features. This stranger that we hope has become a little more known. As usual, let's take stock and try to summarize the salient points that you need to memorize to get a correct idea of what a computer is. Let's say right away that it is a machine, a hardware machine that, thanks to the intuition of Alan Turing and his tape that runs up and down, it is able to process information and support us in an infinite number of daily activities thanks to the software that human intelligence is able to produce. It has a limit. The Turing machine that we are able to build is electronic. It uses transistors, and we are therefore able to realize bits that take on only two values, 0 and 1. It is basically a calculator, because it treats bits as numerical values to which it attributes different meanings only thanks to the software written by a man. Its results are just numbers that, depending on the context, may require transcoding into something else. The software architecture, based on the so-called artificial neural networks, offers the advantage of overcoming the rigid limit of numerical comparison through a gradual approach for successive in-depth analysis, which, despite a certain margin of error, allows layer after layer to identify the result, despite the approximations, because they have been distributed in the various steps. And this is very similar to our way of evaluating reality. So we are facing a very promising new frontier for software and computers. However, there is one last aspect that we would like to highlight, because it is the most important of all. We have deliberately left it in the final slide, so that you can keep it in mind. The computer is extremely fast. A speed that goes far beyond our imagination. We often associate processing speed with intelligence. The computer allows us to do complex analyses and statistics that would require months and months of hard work. The ease with which we can have data and statistics thanks to the speed and data storage of computers leads us to always talk only in terms of numbers. Nowadays we are not credible if we do not include statistics and percentages in our speech. Otherwise we are led to think that the discourse is generic, without foundation. With statistical data, it immediately takes on a different weight. It is definitely a true statement, it is true. Unfortunately, this is not the case at all, because any statistical data is based on input data whose nature is almost always not provided, and is also based on an absolutely subjective point of view of the one who has decided to process that input data in a specific way rather than another. That's not to say that all statistics are wrong. It just means that statistics are numbers, and as such they need to be contextualized. They can say anything and everything. Think about the election results and how all politicians are able to show you that they won despite the results obtained. However, let's conclude with this little game to give you an idea of the speed of computers. That does not mean intelligence. Today's computers on average have an internal clock that runs at 2.5 GHz, meaning that it performs 2.5 billion ticks per second. It executes in only 1 second 2.5 billion slots of Alan Turing's famous tape. Let's imagine that the computer has finished processing and has displayed the result on the monitor. And the user must press enter within a second, and let's imagine that a computer's clock tick is comparable to its breathing. 2.5 billion breaths waiting for the user to press enter would correspond to about 80 years in our life. And if the computer, in a second, completes a very complex processing, the calculation of a statistic, or the production of an image, consider that it took 80 years to do his job. It's fair to say that it took him an entire life. It seems to be not so fast. Thank you all, and we hope you found this presentation useful. Let's leave with Alan Turing's assertion, who said that the computer, the machine with the tape that goes up and down, will be able to equate the human brain when it will be able to replicate it faithfully. And we add, it probably won't be electronic, no more transistor-based. Because logic exists regardless of bits.